The information in this video comes from thorough research. What do you think about the concept of the fourth dimension? Have you ever explored its mysteries and how it challenges our understanding of reality? We'd love to hear your opinions in the comments. Space and time are intertwined, and everything that moves in space also moves in time. Understanding how the fourth dimension works may challenge the human mind. Albert Einstein. Journey to the fourth dimension, exploring the possibility of higher dimensional travel. The idea of traveling to the fourth dimension has fascinated scientists, mathematicians, and science fiction writers for centuries. While we live in a three-dimensional world where objects have length, width, and height, the existence of a fourth spatial dimension opens up a realm of possibilities. What would it mean to move freely through this dimension? Could such movement allow us to bypass the limitations of three-dimensional space, enabling faster-than-light travel, time manipulation, or even interaction with parallel universes? Albert Einstein's theory of relativity introduced the idea of time as the fourth dimension, forming the fabric of space-time. However, mathematical and physical theories, such as string theory and M-theory, suggest that additional spatial dimensions may exist beyond our perception. If this is true, could we ever access or navigate them? Could higher dimensional beings exist that observe our world in ways we cannot comprehend? This article provides an in-depth exploration of the fourth dimension, covering its historical origins, its implications in physics and mathematics, and its representation in culture and science fiction. We will also examine the challenges and possibilities of traveling to this mysterious dimension, as well as its potential impact on humanity's future. Historical perspectives and theories on the fourth dimension. Early philosophical and mathematical concepts. The concept of dimensions beyond the observable world has been contemplated since ancient times. Greek philosopher Plato, in his famous allegory of the cave, suggested that humans may only perceive shadows of a greater reality. This allegory hints at the possibility that our three-dimensional world might be just a limited view of a higher dimensional existence. In the 19th century, mathematicians began to rigorously explore the idea of higher dimensions. German mathematician Carl Friedrich Gauss suggested that geometry might exist beyond three dimensions. However, the most significant breakthrough came from Bernhard Riemann, whose 1854 lecture on the hypotheses which lie at the foundations of geometry introduced the idea that space could have more than three dimensions and that its shape could be influenced by mass and energy. Another crucial milestone was Charles Howard Hinton's work in the late 19th century. Hinton coined the term tesseract to describe the four-dimensional analog of a cube and developed visualization techniques for understanding higher dimensional objects. Einstein's theory of relativity in the fourth dimension. Albert Einstein's special and general theories of relativity revolutionized our understanding of dimensions. His 1905 special theory of relativity introduced the idea that time should be considered the fourth dimension, forming a unified space-time continuum with the three spatial dimensions. This concept meant that space and time were interconnected, and movement through one affected the other. General relativity, published in 1915, expanded on this idea by showing that massive objects warp space-time, creating gravitational effects. While Einstein's fourth dimension is temporal rather than spatial, his theories provided the foundation for later explorations into the existence of additional spatial dimensions. The fourth dimension in modern physics. Higher spatial dimensions in string theory and M-theory. One of the most significant modern theories that suggests the existence of higher dimensions is string theory. According to string theory, the fundamental particles of the universe are not point-like objects, but tiny vibrating strings. For these strings to behave consistently within the framework of the theory, additional spatial dimensions are required, typically 10 or 11 dimensions in total. M-theory, a unification of various string theories, proposes an 11-dimensional universe, where our three-dimensional world could be a brain floating in a higher dimensional space. These extra dimensions might be compactified, curled up so small that they are undetectable to our senses. However, If they exist, they could theoretically allow for higher dimensional travel. Wormholes and higher dimensional travel. One of the most exciting possibilities of higher dimensional space is the existence of wormholes, hypothetical shortcuts through space-time that could allow travel between distant points in the universe. If additional spatial dimensions exist, they might provide a means to stabilize and navigate wormholes. Mathematically, wormholes arise as solutions to Einstein's field equations. However, to keep a wormhole stable, exotic matter with negative energy density would likely be required. While no such material has been conclusively observed, the possibility remains an active area of research in physics. The role of higher dimensions in quantum mechanics. Quantum mechanics also hints at the possible existence of higher dimensions. The famous double-slit experiment suggests that particles exhibit wave-like behavior, implying that reality may be structured in a way that we do not fully understand. Some physicists propose that quantum entanglement and other phenomena might be explained by interactions occurring in higher dimensional spaces. Mathematical models of the fourth dimension. Visualizing the fourth spatial dimension. Since humans are limited to perceiving three spatial dimensions, visualizing a fourth spatial dimension is challenging. However, mathematics provides tools for conceptualizing it. One of the best-known four-dimensional objects is the tesseract, or hypercube, the four-dimensional equivalent of a cube. Just as a cube consists of 6 squares, a tesseract consists of 8 cubes. Another way to understand the fourth dimension is through cross-sections. If a three-dimensional object passes through a two-dimensional plane, a 2D being would only see cross-sections of it. Similarly, if a four-dimensional object passed through our three-dimensional space, we would only perceive three-dimensional cross-sections of it. Non-Euclidean geometry and curved spaces. The fourth dimension also plays a crucial role in non-Euclidean geometry, where space can be curved rather than flat. This concept is fundamental to general relativity and our understanding of the universe's shape. The fourth dimension in science fiction and culture. Literature and films inspired by higher dimensions. The fourth dimension has been a popular theme in science fiction for over a century. Some notable examples include Flatland, A Romance of Many Dimensions, 1884, by Edwin Abbott, which explores higher dimensions through a two-dimensional being's perspective. The Time Machine, 1895, by H.G. Wells, which introduced time as a fourth dimension. Interstellar, 2014, which features a five-dimensional tesseract where time is manipulated. Philosophical and existential implications. The existence of higher dimensions raises profound questions. Could intelligent beings exist in higher dimensions, perceiving our world in ways we cannot? If the fourth dimension exists, could it allow for new forms of consciousness or reality? Practical implications and future prospects. Technological challenges and theoretical possibilities. Even if higher dimensional travel is theoretically possible, creating the necessary technology poses significant challenges. Advanced physics, quantum computing, and breakthroughs in energy manipulation may be required to interact with or navigate higher dimensional spaces. Scientists are currently exploring quantum gravity and other exotic theories that might provide insights into achieving such a feat. Potential applications of higher dimensional access. If humanity were to unlock the ability to access the fourth spatial dimension, the implications would be groundbreaking. Instantaneous travel. Higher dimensional movement could provide a means for instantaneous or near-instantaneous travel between distant locations, revolutionizing space exploration. Time manipulation. If the fourth dimension allows access to alternate timelines or time loops, it could change our understanding of causality and history. Parallel universes. Some theories suggest that the fourth dimension may connect to parallel universes, opening possibilities for interdimensional exploration. Ethical and philosophical considerations. The ability to move beyond three-dimensional space raises ethical and philosophical dilemmas. Would altering events through higher dimensional travel disrupt the fabric of reality? If intelligent beings exist in higher dimensions, How would our interactions shape our future? The fourth dimension, whether viewed as time and relativity, an extra-spatial dimension in string theory, or a realm of imagination in science fiction, offers a fascinating glimpse into the unknown. While direct travel to a fourth spatial dimension remains beyond our current technological capabilities, scientific research continues to explore its possibilities. If higher dimensions exist, they could revolutionize our understanding of the universe, unlocking new pathways for space travel, time manipulation, and even consciousness expansion. Until then, the fourth dimension remains a realm of wonder, one that bridges the gap between science, mathematics, and a limitless imagination of the human mind. Thank you for joining me on this journey. If you have any experiences related to this topic, be sure to share them with us. Until the next episode, be mindful of the energies around you